In the next part of our seminar, we are going to use the compound interest formula. The compound interest formula says the principal you put in times 1 plus r over n. R is your interest rate. N is the number of times it's compounded each year. So if it's compounded yearly, n would be 1. If it's compounded semi-annually, n would be 2. If it's compounded quarterly, n would be 4. It's compounded monthly, n would be 12. It's compounded daily, n would be 365. And then t is the number of years you're going to leave your investment alone. So let's take a look at example 9. It says, Mrs. Salzman invested $2,000 into an educational account for her daughter when she was an infant. The account has a 5% interest rate. If Mrs. Salzman does not make any other deposits or withdrawals, what will be the account balance after 18 years if the interest is compounded quarterly? I'm going to highlight that quarterly for us. So in other words, let's write down our formula. So A equals P times 1 plus R over N raised to the NT power. Let's write down what we know. Well, P is how much money she's going to put into her account. So P is 2,000. R is going to be your interest rate, which is a decimal, is 0.05. N is quarterly, which is 4. T is their time in years, which is 18. In other words, we can write this as 2,000 times 1 plus 0.05 divided by 4 raised to the 4 times 18 power. We can simplify that a little bit, so we can get 2,000 times 1.05. 4 times 18 would be 72. That's what we're going to do. So let's go use our calculator and find that. I'm going to use a scientific calculator this time because you don't need all that power. So we're going to say 2,000 parentheses 1 point, what do we say? I'm so absent-minded. 1.05, and we're going to raise that to the 72nd power. So she's going to have about $67,090 in the account. Except, you know what? That's not right. 0.05 divided by 4 is not 0.05. Sorry about that. So I have to go back in here. That seems kind of ridiculous. There we go. She's going to have $4,891.84. So she's got 2.5 times her money pretty much. Now let's take a look at example 10. Same thing. The only difference is we're going to compound it monthly this time. So let me write down the formula. A equals P times 1 plus R over N raised to the NT power. So 2,000 times 1 plus 0.05. We're going to divide it by 12 this time. We're going to take it times 12 times 18. So the only thing we're doing is everything else is staying the same. And we're going to see how much money she'd have if we compound it monthly. So 2,000, let's actually do it this time. 0.05 divided by 12. Oh, that's an ugly decimal number. I'm going to leave it alone for now. But let's take 12 times 18. So 216, so we're going to compound it 216. So 1 plus 0.05 divided by 12 raised to the 216th power. But of course we have a smaller time because we're splitting that up. So now, let's do it. So we're going to say 2,000 parentheses 1 plus 0.05 divided by 12, and we're going to raise that to the 216th power. And you get a little bit more money, don't you? $4,910. And what do we say, 2 cents? And finally, on example 11, the only difference is we're going to compound that daily. So we're going to say 2,000 times 1 plus 0.05 raised to, or divided by 365, raised to the 365 times 18. I think I'm just going to put this all in the calculator this time. So 2,000 times 1 plus 0.05. Whoops, forgot my 1. You back that up there. And I'll just start again. 2,000 parentheses 1 plus 0.05 divided by 365. We're going to raise that. Now, I think I'll put this in parentheses just to make sure. 365 times 18. Notice it's really not that much more, is it? $4,918.90.